Good evening, everyone. I am Shiva Prasad, and my teammates are Venkat Sai Krishna and Purna Chandar. And my topic is about smart and secure agriculture in desert areas using 5G and IoT with machine learning. Abstract. In this project, we are not only detecting and identifying crop diseases, but also predict required amount of chemicals to avoid diseases or to control pests. We will monitor crop using 5G connection and IoT devices, where IoT devices will capture crop images and then using 5G connection will send that images to centralized server, where machine learning algorithm will predict diseases and suggest chemicals to the farmer. Introduction. Agriculture was a key development in the rise of human civilization. So, according to the forecast data, by 2020, there may be a chance of increase of population over 25%. So, as the population increases, we have to increase the crop production. To increase the crop production, the crop yield, we are using some fertilizers which are not suitable to the soil, which results in soil erosion. Hence, if we see here, if we see not only for food, but also for crop production, is becoming equally important role in economics of many nations. Existing system. They used to follow olden days practices for doing agriculture. They are used in only some parts of rural and urban areas. Due to lack usage of IoT and digital server, IoT tools and digital transformation in rural areas, these technologies are not properly used. And the disadvantages are it is difficult to identify crop diseases. It is a time-taking process. There is no usage of drones and implementation of such advanced technology due to lack of network connectivities in the rural areas. And the next will be continued by my friend.
Proposed system. In this project, we are not only detecting and identifying crop diseases, but also creating a required amount of chemicals to avoid that diseases or to control pests. There will be the proper usage of drones by which we will monitor crop using 5G connection and IoT devices, where IoT devices will capture crop images and then using 5G connection, we will send that images to the centralized server, where machine learning algorithms will predict disease and suggest chemicals to farmer. But nowadays we don't have that type of IoT devices, so we use the plant village disease dataset, which contains more than 20 different diseases. Advantages: it is easy to identify crop diseases. Using IoT and machine learning, we can reduce the human effects. By using this IoT and machine learnings, the crop is secured without any disease. It reduces the time efficiency. System architecture. In system architecture, we use various type of clouds like sensors, cultivation, drones, satellite images. By using sensors and drones, we send that images through internet and they store that images in local data storage, by which we can tell the farmer about the smart farming. In smart farming, we can monitor the crop health monitoring, self nutrient measurement, and crop yield prediction, pesticides management, fertilizer management, and irrigation management. By all these, we can produce the crop yield by telling the farmer to use this type of chemicals for crops. Next.
Algorithms. CNN, convolutional neural network. A convolutional neural network is a type of artificial neural network used in image recognition and processing. It is a deep learning algorithm which can take in a input image, assign importance to the variance objects in the image, and able to differentiate one from the other. SVM, support vector machine is a machine learning algorithm that analyzes data for classification and regression analysis. It uses a technique called the kernel trick to transform your data, and then based on this transformation, it finds an optimal boundary between the possible outputs. System requires. We need some software requirements like operating system more than Windows 7 plus. Python IDE, we are using Python 3.9 3.2.7 Python charm. We need a hardware recruitment like a RAM 4 GB and more and higher, processor i3 processor. Hard disk we are using 500 GB. We are using some modules, so or 6 types, and uploaded crop diseases. In this module, users will upload different crop diseases dataset details. And next, image processing and normalization. In this module, all images and are resized into equal size. Build crop diseases and chemical definition model. In this module, train CNN model with above images and the calculate CNN prediction accuracy on the test images. After we run multi-class SVM algorithm. In this module, dataset used to train SVM with above dataset and to the get its accuracy. And upload test images and predict disease and chemical. In this module, user upload the test dataset to identify disease and predict chemical. And finally, we use accuracy log graph. In this model, accuracy graph is shown. Conclusion: we implemented this project not only about the detecting and identifying crop diseases, but also predicting a required amount of chemicals to avoid the diseases or to control pests. For example, in this we will monitor crop using 5G connection and IoT devices, where IoT devices will capture crop images, and then using 5G connection will send the images to centralized servers, where the machine learning algorithm will predict disease and suggest chemical to farmer. But we don't have such IoT sensors. So we are using plant village disease dataset, which contains more than 20 different plant diseases. Thank you.